use for what. If you remember nothing else from this whole webinar, hold on to this slide here. Biodiversity is spatial. A square kilometer of Ottawa is very, very different than a square kilometer of the Congo Basin rainforest. Second, measure the thing that you actually care about. You can't measure carbon sequestration or the color green and assume that what you're getting at is biodiversity. And third, it's very common for targets in the reporting around the projects that we do to be reported around an area of land that is better protected. For example, number of hectares restored or percentage of land or marine area that is protected, and then automatically assume that that is better for biodiversity. Because of the spatial nature of biodiversity, this can be really problematic because it incentivizes conservation in the cheapest and the easiest places, which may not be where the biodiversity is at all. If we want to protect Zoe or Veronica, it might be a good idea to make a protected area around the chairs where they're sitting. If all that we're reporting is that we protected 100,000 hectares somewhere, we might discover that those are mostly in the parking lots outside the buildings and don't include their chairs at all. This can even have perverse outcomes because if you protect areas just based on numbers and those turn out to be areas that don't matter, then the impacts are actually driven towards the areas that do matter. Next slide, please. So what does a useful biodiversity metric look like? I would argue that there are 5 characteristics that make a metric useful. The first is that it needs to be based on one of the key components of biodiversity. That's species, ecosystems, or genes. It needs to be spatially explicit because a square kilometer in different places is very different, and any type of metric that is going to work globally needs to be able to take that difference into account. It needs to be quantitative. So a change in biodiversity needs to be proportional to a change in the metric so that you can compare a number between different places or different project sites or add them up across different project sites. And that gets me to the next point, which is that it needs to be additive. You need to measure it in the same way based on the kind of standard data that lets you combine all of these individual metrics together and understand how one project fits into the landscape, fits into all the projects happening in a country, fits into all the projects happening in all the countries, and adds up to the global target. And finally, it needs to be temporally responsive. It needs to change on timescales that are relevant for decision-making and project work. Otherwise, it's very hard to tie it to actions that are actually happening on those tighter timescales. If a metric doesn't do those 5 things, it's really hard to use it. Next slide, please. STAR exists to respond to this very specific need. At its root, STAR tells you how much global conservation gain you could achieve through a given action in a given place. It's based on the IUCN Red List of Threatened Species. It was developed by a simply massive consortium of over 50 conservation organizations, including many Canadians, Government of Canada employees. It was published in Nature in 2021. It's designed to help everyone from governments to investors to businesses and project managers target actions and investments to achieve conservation outcomes and contribute to global policy aims. It measures the potential contribution of 2 different kinds of actions to reduce species extinction risk. Threat abatement, that's actions to address threats to species in their current habitats. And restoration actions, actions to restore habitat and address threats to species in places where they used to live but have since been extirpated. And it works by drawing on information about where species live, how threatened they are, and why they're threatened. Next slide, please. This information comes from the IUCN Red List of Threatened Species. If you haven't come across this before, this is quite simply the world's most comprehensive compendium of the information about life on Earth. It's a barometer of life, and it's basically a database of the global conservation status of animal, plant, and fungi species. Species assessments are conducted following a standardized and rigorous process using the IUCN Red List categories and criteria based on an objective system for assessing the risk of extinction of a species based on past, present, projected threats. It's a lot more than just a list of species and their status. It also provides information about species ranges, their population sizes, habitat, ecology, use, trade, threats. For a lot of businesses, it contains not only information about the endangered species, but also those that might be sensitive to development, such as species with restricted ranges or that are endemic to a particular area. And it's developed and maintained by over 10,000 of the world's expert scientists volunteering their time. And all of that information is what powers the STAR metric. Next slide, please. So how does this actually work? Well, let's imagine that we have a site that contains 3 species. The entire global range of a frog species listed as vulnerable on the red list, about half of the global range of an endangered hummingbird species, and a much smaller percentage of a critically endangered monkey. Each of those threat categories comes with a different STAR weighting. And what STAR does is stacks all of those ranges up like pancakes. Next slide, please. And then imagine that the area of interest dotted line was a cookie cutter. It slices out that area of interest and calculates the STAR score for the whole site based on the number of threatened species, their threat categories, and the proportion of the ranges included at the site. So if you look at this slide, you see that the vulnerable frog has a lower weighting, but because it has 100% of its range in the area of interest, it's weighted by 100%, whereas the critically endangered monkey gets a rating that's sort of weighted higher than the frog, but it only has a smaller percentage of its population or range within the area of interest, and so it's multiplied proportionally. All of those are then added up to give you the STAR score for the site. And this is how it works to calculate the STAR score at any site of any size anywhere in the world. Next slide, please. Each species can be threatened by a specific combination of threats. And these are threats that are assessed during the assessment process of the individual species onto the red list. And they're a standard categorization of threats, which is important because that's what lets you combine across all of the different assessments across the 160,000 species in the red list. But because each species can be threatened by a specific combination of threats, the STAR score for the site can be broken out by threat type. This is important because threats are what you act on with a project or investment. Let's say we're going to put a protected area at this site. Or implement a policy that will directly or indirectly stop biological resource use like hunting. That action could deliver 18% of the total reduction in global species extinction risk possible at this site. In contrast, another threat, for example, pollution, has a much lower theoretical ceiling of global species extinction risk that it could reduce. So if you're just deciding what type of action to do at the site based on how much species extinction risk you could reduce, choose biological resource use, not pollution, as the target of your policies. Next slide, please. This is really useful for many different types of actions, from undertaking assessment across a project portfolio. Let's say you want to compare the amount of global species extinction risk that could potentially be achieved at different sites in a portfolio, or identifying the co-benefits as a result of particular actions and policies that you're taking at sites that might not be targeted at biodiversity, but it can be linked back to those particular threats that can be quantified as parts of the STAR metric. Next slide, please. If we look at those threats, adding up all of the STAR scores across the entire world, here's what we see. And this is the terrestrial stack that we're seeing, not the marine stack. Big picture, we see that the biggest threats come from annual and perennial non-timber crops and logging and wood harvesting, and improving sustainability of crop and timber production represents 40% of the global opportunity for reducing species extinction risk by acting on the terrestrial landscape. Thinking about it another way, key biodiversity areas that have been identified using a protocol and process as areas that are essential for the persistence of biodiversity in the world, only make up 9% of the surface area of the land, but actions within key biodiversity areas capture 47% of the total species extinction risk reduction possibility. So they're really important places to be working or protecting. At sea, the picture is a little bit different. The biggest threats come from unsustainable fishing, and reducing that threat could achieve 43% of the opportunity for reducing species extinction risk. 75% or 3/4 of the global marine opportunity falls entirely outside of the boundaries of protected areas, and only 2.7%, less than 3% of the opportunity for reducing species extinction risk at sea falls within no-take protected areas. Next slide, please. This is what the STAR threat abatement layer looks like for the entire globe. And what you see is that STAR scores, so places where you have the highest opportunity for reducing global species extinction risk, are their highest where there are many threatened species with small ranges. Because one of the things about how the metric values biodiversity is every species is valued the same. Those are tropical mountains or islands that often have high STAR threat abatement scores, meaning that actions in those places will have relatively high impact on reducing global species extinction risk. And an important consideration here is that species extinction risk is only one aspect of biodiversity importance. It's the aspect that we understand the best because it's been studied the longest. But that doesn't mean that an area that has a low STAR score is not necessarily, it doesn't mean that it's not important for nature. It could be important for nature for other reasons. Next slide, please. This is looking at the restoration layer, so the opportunity for reducing global species extinction risk through actions to restore previous habitat of species or abate threats in those areas, and parts of the world where threatened species have lost large proportions of their historic range tend to score highly for STAR restoration. These are sometimes, but not always, the places that have high STAR threat abatement scores. If you look across North America, that large green area in the central United States and southern central Canada reflects species of the Great Plains and grasslands that now have much, much reduced ranges. Next slide, please. So let's put this into the bigger context and think about Goal A of the Kunming-Montreal Global Biodiversity Framework. Collectively, as a world, we have promised to reduce by tenfold the extinction risk of all species by 2050. Basically, we can't do that without a common metric like STAR because we won't know how to measure and organize all of the individual actions and projects across all the different sites and all the different types of societal actors to add them up to know what we're actually doing and what we need to do. STAR scores can be broken down to show the contributions of individual threat types, as we saw before, or individual actions. That could be a government establishing a no-take zone or marine protected area, yielding an increase in ecotourism, or finance supporting sustainable management of commercial fisheries. These can all be added up together to quantify the contributions across a variety of different sites. Next slide, please. What this lets us do is evaluate how these different actions or potential actions would contribute to a country's national star score, and by extension to a country's national contributions to the Goal A of the Global Biodiversity Framework. Next slide, please. Because biodiversity is spatial, actions in different countries represent different theoretical opportunities for contributing to Goal A and reducing global species extinction risk. The three countries with the highest national star scores are Indonesia, Colombia, and Madagascar. So based on absolutely nothing else, if you're deciding where in the world to work and your goal is to reduce global species extinction risk, you might want to take this into consideration. Next slide, please. So what would one of the ways be that we could use this on the ground? The first step is to establish a quantitative star target aligned with and contributing to national or global goals. Next slide, please. Then you could screen different potential areas of interest within your landscape for possible interventions. These could be sites where you're already working, or they could be new sites where you're not working yet. And then you can see that, for example, these three areas of interest, A, B, and C, have different potential biodiversity benefits, different potential ceilings in terms of the amount of global species extinction risk that could be reduced through actions that happen in those sites. Next slide, please. In this case, site C has the potential to contribute 20 star units. Next slide, please. And then if you've chosen that site based on its highest potential, you can identify specific conservation actions to address threats, to achieve a target and their corresponding star scores. These could be actions that were identified directly from the star analysis, or conversely, a star assessment of actions driven by other considerations, such as climate adaptation goals. All they have to do is be able to be tied back to threats. The abatement of different threats is going to have different potential star values, as we saw with biological resource use and pollution before, based on the particular threats of the species site, weighted through the star calculation. Next slide, please. If you've been following STAR closely over the last few years, you knew some of that before, but there's an enormous amount of development that's underway right now that I think is pretty exciting. Next slide, please. The first near-term development is calibrated STAR. And this is important because estimated STAR that uses the global red list assumes that threats and populations are evenly distributed across a species area of habitat. And while this is a necessary assumption to make for screening and planning, we know it's often not true. And directing action on the ground will need more site-specific information. This is where calibrated STAR comes in, taking the estimated STAR that uses the global data sets and ground truthing and validating it at a site to test those two assumptions, and then providing a calibrated value that can be used for tracking and reporting how much realized STAR is actually delivered through conservation actions or indirect actions that are going to have a conservation impact. This is cutting edge development and testing right now. There are manuscripts under review at journals that are going to be published hopefully extremely soon. But the big picture is about sort of taking the global data sets that have these assumptions based in, not because it wouldn't be amazing to have population maps and threat maps across the 160,000 species assessments, but just because this information doesn't exist yet. and taking those and ground truthing it at the site where the fine scale thing might be kind of different. You sort of imagine the house where you live. Um, it's probably a pretty good estimate that at night you're going to be found in your house, but that doesn't necessarily mean you're going to be found in your kitchen. You might be found in your bedroom, and you're going to need some information about what's actually going on in the house to understand that. Next slide, please. Beyond calibrated star, there are a couple other near-term developments underway. The original star layer and the one that is in the integrated biodiversity assessment tool and the contributions for nature platform, which I'll talk about a little bit more in a little bit, is based on terrestrial birds, mammals, and amphibians. Incorporating additional taxonomic groups is a top priority. Star for marine environments was just published in Nature last year. Star for freshwater environments is under review right now. And the plan is to include reptiles and trees over the course of this year as well. The current layer is at a resolution of 5 by 5 square kilometers, and work is underway to increase that to 1 square kilometer resolution. And likewise, there's a whole development frontier around automating the calibration or ground truthing of star to make it easier to use, including incorporating satellite and other remotely sensed data to reduce the burden on the actual site where the calibration is being done. Next slide, please. So that's a taste of what STAR is, what's coming down the pipeline over the next year. What are some of the ways that it's being used today? STAR is already being used by many types of actors across conservation. I just want to give you a couple examples to help illustrate a small subset, a taste of the things that are possible. Next slide, please. For example, in work led by IUCN's Mesoamerican Regional Office, STAR is being used to help support the protection of rights and territories of Indigenous peoples and understand and quantify the opportunity for conserving biodiversity within those territories. Next slide, please. In another example, and this is work commissioned by the European Commission, STAR was used to identify opportunities for implementing the EU's biodiversity strategy by quantifying and mapping high-value locations for addressing the threats of invasive alien species. By extracting the slice of star that was associated with that threat in the same way we looked at the slice of star in that example that it was associated with biological resource use. As you can see in this, next slide, please. No, the next slide, please. That's perfect. One of the things this analysis showed was just how much of the EU invasive species target could be met through managing a small number of specific invasive alien species like goats in a small number of specific places like the Mediterranean islands. Next slide, please. A lot of the work testing star calibration and developing these methods has been in collaboration with the private sector, where workshops have been used to conduct star calibrations, testing those assumptions at your site. Are the species that you are predicted to be there actually there? Are the threats to those species that are predicted to be there actually there? Next slide, please. One of the things these workshops have actually done is calibrated the star value and then identified indicators tied to those individual threats in order to calculate the amount of realized star that is actually delivered over the course of those projects. Next slide, please. And then a major challenge today is that calibrating star is pretty labor intensive because of the data and information required. It's not always going to be possible to have a workshop of 20 of the experts on a particular site. So a particularly cool new project in collaboration with NASA and the Global Environment Facility is working from Mexico to Panama to develop the way to use remote sensing to simplify that process and understand to what extent we can measure those threats to species and the changes in those threats from space. Next slide, please. A lot of the work has been conducted with the private sector, with a growing number of companies around the world using STAR including Swedish forestry company Stora Enso, who are integrating STAR into the digital twin of their 1.4 million hectare forest holdings in order to proactively manage biodiversity, to understand where changes in their holdings can have an impact on reducing global species extinction risk. Next slide, please. And over in the Mediterranean, the STAR metric was sliced not on invasive species this time, but solely to focus on threats from agriculture, the biggest slice of the terrestrial opportunity for reducing global species extinction risk, much as was done in the large IUCN flagship report earlier this fall, in order to understand where working on threats to species from agriculture could achieve the greatest benefits for reducing global species extinction risk. Next slide, please. Turning to Francophone Africa and Asia, in work funded by Agence France pour Développement, and working across 16 different countries, STAR was used to help assess economic sectors in each country that would have the greatest opportunity for improving biodiversity. Next slide, please. And STAR is also the species metric for the IUCN Measuring Nature Positive approach for species and ecosystems, an initial version of which was put out to membership consultation last year, and an interactive version 2 that will be published by the World Conservation Congress in October in Abu Dhabi in the fall, and will include STAR. And so these are just sort of a slice of a number of different examples, but the picture that I want you to take away is that once you have a common metric, once you have a way of quantifying and measuring the opportunity for reducing global species extinction risk, the same way everywhere in the world at different scales that's standardized, the ability to apply this to answer slightly different questions it's really limited by your imagination. And that's what's so powerful about having this type of sort of universal transferable metric. Next slide, please. So what does that mean for you? Well, let's take a short quiz. Really, there are two questions here you should ask yourself. Is the project you are working on, planning, or fundraising for likely to affect species or ecosystems either directly or indirectly? And two, can you draw the place you're working on a map? If you answered yes to both of those questions, then use STAR, or at least use estimated STAR, which you can calculate automatically for free if it's for non-commercial use, and will quantify for you the answer to this question of just how much global species extinction risk you could reduce through actions that are taken in that site. Next slide, please. Here are the types of things that a STAR analysis could let you or your project partners, be they governments, corporates, or civil society, say. They could let you understand that a particular project represents 5% of a country's potential opportunity for reducing global species extinction risk towards delivering Goal A of the Kunming-Montreal Global Biodiversity Framework. They could let you compare different types of sites in a country. For example, saying protected areas and OECMs, other effective area-based conservation measures in a given province represent 40% of the provincial opportunity for contributing to Goal A. They could let you compare between different sites in your portfolio or different sites in different actors' portfolios and say actions to abate threats in project site A have 3 times as much potential for reducing global species extinction risk as those taken in project site B. Next slide, please. They could tell you that one threat is better to focus on than another threat, and tell you that actions to address threats from invasive species at a project site A have 10 times the potential for reducing global species extinction risk as actions to work on pollution at the same site. Or they could quantify the biodiversity co-benefits that come from climate adaptation actions taken at a project site and tell you that those represent a given percentage of country X's opportunity for reducing global species extinction risk. A lot of really useful things to be able to say and understand when you're directing work on the ground or fundraising for future work or developing a proposal. Next slide, please. Here's a slide to take a photo of if you want to find out more. There are guidance documents and infographics and issues briefs and YouTube videos, all describing STAR. There are specific guidance documents targeted towards governments and civil society that are being developed under the NAbSA project and will be available to all of you shortly. There's an email address there if you have specific questions, star@iucn.org. There's a host of things that you can find out more about this and how to use this. This is truly one of the exciting things that happen right now. I don't know if we're going to send you the PowerPoints, but the presentation is being recorded, so I suspect that this information will be available to all of you. Where do you access STAR? Next slide, please. There are basically two places to access STAR. The first is the Contributions for Nature platform, and this is for situations where you're confident the work is going ahead as it becomes public once the contributions are validated. Global Affairs Canada and IUCN Science Team are working to upload your NAbSA projects into this at the moment, auto-generating STAR analyses that show you that threat stack that we talked about. Next slide, please. Little bit about the contributions platform. It's the place for all constituents associated with IUCN to document what they are or will be doing to contribute to nature and global environmental goals. It was created with the mandate of IUCN's membership under the IUCN program Nature 2030. Starting at home, these global goals are in the IUCN program itself, but they also go beyond to look towards intergovernmental targets like the Kunming-Montreal Global Biodiversity Framework. And there were sort of three different things that the members were looking for when they mandated this platform. They wanted it to be as light as possible while still being informative. So as easy as possible to use. They wanted it to build from available information wherever possible. And crucially, they wanted it to reflect the enormous spatial variation around the globe. That's variation in nature itself, variation in threats to nature, variation in capacity to respond to nature, and also to be considerate of reservations and restrictions around data sharing. Next slide, please. The core of the platform is a spatial one. The way that constituents interact with it are through maps, places where they're conducting conservation or restoration efforts. We also had a temporal dimension pinned to the Nature 2030 program. And then the core spatial data is supplemented by some non-required fields, and it goes through some light touch validations. Putting together, all of that gets combined with high resolution spatial metrics. There's a carbon calculator for documenting global goals for climate mitigation, and for biodiversity, there's STAR, derived directly from the IUCN Red List. Next slide, please. The platform allows IUCN constituents, such as Global Affairs Canada, to enter spatial data on the places where they're undertaking conservation or restoration actions over the course of the decade. These contributions are then meticulously validated through IUCN regional offices, ensuring a high level of accuracy and minimizing errors in data entry. There are three different parts of the platform. There's a data entry module facing towards IUCN constituents. There's a validation module where those entries get checked. And then there's a visualization module that is public and allows public visualization of the contributions, making the data accessible and transparent. And this is what's going to happen to all of your projects with spatial data. Next slide, please. In the visualization module, and I think it's since been updated to look more impressive than this, or at least a better color scheme. You can see the currently validated contributions. Currently, there are over 10,000 of them around the world. The focus is on maps. It kind of feels like Google Maps when you're zooming in and out. And it automatically calculates global statistics on contributions to global goals for conservation, restoration, and climate change at an aggregate level. Next slide, please. And then it disaggregates those into reports by region, country, organization, type of organization, individual contribution, basically any slice that you can imagine. Here's a report for Africa. And there are summary statistics around the percentage or the regional conservation opportunity that the current contributions within that report set have the potential to meet. Next slide, please. When you zoom into the visualization of a specific contribution, such as one of the ones that is uploaded by Global Affairs Canada and are currently being validated, this one is uploaded by BirdLife International and Nature Canada in the Douglas Lake Plateau, important bird area. You can get a sense of the breakdown of the star threats, that stack on the right-hand side, and the relative potential of that contribution to meet Canadian, North American, or global targets through acting on each of those threats in that site. Next slide, please. As I mentioned, STAR is the basis of quantifying the potential contribution gain or conservation gain that could be achieved by the individual contributions in the platform. There's 10,130 right now, and those represent 18% of the total global STAR threat abatement and 12% of the potential STAR restoration opportunity. And there are a number of platforms that do various things floating around at the moment, and I think there are three things that make this platform helpful and unique. The first thing is that it has a mandate. It's not just an academic lab that came up with this. There's a mandate from IUCN's government and civil society members to build this. They're the ones putting in the information. It's spatially explicit, which is really important for all of the reasons that we talked about before. Gone are the days when a project that works on the ground can make claims about what they're doing without actually being able to draw where they're working on a map. It's also quantitative and it's validated. And those three things make it a little bit different than a lot of the other platforms out there. Next slide, please. The other way to access STAR is through the integrated biodiversity assessment tool. This would be for work that needs to be private because it won't be public. It'll just provide you the information that you need. And it is free for non-commercial use. It's an alliance between basically the four biggest conservation data providers: BirdLife International, Conservation International, IUCN, and United Nations Environment Program World Conservation Monitoring Center. And what it is, next slide, please, is the way that the three core biodiversity data sets we have: the World Database on Protected Areas, the Red List of Threatened Species, and the World Database on Key Biodiversity Areas, are served for commercial use. And you can see that they're all updated at least twice a year. STAR comes through that as one of the derived products of the Red List. And importantly for us here, while this is how you access them for commercial use, for non-commercial use, you can access them for free. And finally, in the future, we're anticipating serving this through the IUCN Red List of Threatened Species website as well. And with that, next slide, let me just say that this has been it's a truly enormous effort. There are literally dozens and dozens and dozens of people working on this across conservation. I'm just the one who happens to be here. And thank you so much for your attention. And I'd be really happy to answer any questions and try to dive a little bit deeper into anything that I wasn't able to cover. Thank you very much.
Thank you so much to you, Nicholas. I have to say, I really, really like the presentation. Very, very detailed and even answering some of the questions that I used to have for STAR. I would like to, I know, I was listening to you, and one one sentence you say came to my mind. I think is very important, especially when we are presenting these kind of tools that we can feel like very difficult to work with. But you say the restriction is just in your imagination. So I think there is no restriction. Maybe it looks difficult, but definitely is workable. So now, please, colleagues, if you have any question, you can also raise your hand because we have the option also to give you the floor. So please feel free to any question. Nicholas is here with us, and all questions are very valid. There are no questions yet. So maybe, meanwhile, I will ask you something, Nicholas, more on the lines of the calibrated star. I was wondering if you were giving some specific cases, but could you give us like some more specificities on the why to do the calibrated star?
Yeah, absolutely. And I think there's sort of two main things that it's important to think about when I'm thinking about how to use biodiversity data. And that is to not get caught in the trap of comparing the data that currently exists in the world to the data that I wish existed, and comparing instead the data that currently exists in the world to freely against a sort of anything else that might exist. And so when you do estimated star, it's solving sort of a different problem. It needs to be able to give you an answer pretty quickly, and it needs to be able to give you an answer very easily. So on the order of sort of minutes to hours of work. And that's why it draws from global data sets. When a red list assessment is done, let's say we're assessing tigers, what it looks at globally is what are the threats to tigers and where do the tigers live. But it doesn't tell you sort of what the population distribution looks like at any one time across that range of species. And that means that when we combine all of the different 160,000 red list assessments together and slice it out with a cookie cutter, you might be broadly in a habitat that is suitable for tigers, but there might not actually be any tigers at the site where you're working. And that's why calibrated star is so important, because it needs to test at the site where you are whether the prediction that there are tigers there is true or not. And if there are no tigers there, then they shouldn't be included in the star score. It's not going to help you very much to do actions that are working on the threats to tigers if there aren't actually tigers there. And a similar thing about the threats. You could imagine that there is a species that is threatened by hunting, for example, generally in its range. But in the particular place where you're working, hunting might not actually be a problem for a number of reasons. And so it's not a good use of your time and energy to take actions that sort of work on star or work on the threat of hunting if there isn't actually hunting at that site. And conversely, you might discover at the site that there are species that weren't predicted to be there that are actually there because of climate migration or gaps in the overall data, and threats might be there too that aren't predicted to be there. And so what the calibration does is it just sort of ground truths and adjusts that overall score so that when you are working against those specific threats at the site, they're working against reality, not against sort of what a prediction is. That's why it's so important.
Yeah, well, definitely super interesting tool. May I'm checking the chat. No questions yet, so I think I will just go with myself and take advantage of that. So, so far you have been showing different case studies, quite pretty interesting. I come from south of Spain, and I was quite impressed to see like all the issues with some in terms of threats for agricultural systems especially in the south of Spain. But in overall, in the different analyses that you have been running so far, you say in Asia, Africa, Latin America, and so on, what are the common challenges that you have been facing across this assessment, or it is something that is really commonality?
It's a good question. And I think that there are sort of a couple different ways to think about that. In terms of sort of actually applying the star metric in particular places, there are sort of differences in how good the data is in different parts of the world, and are going to affect the difference, or the scale of the difference that we see between estimated star, which uses the global data sets, and calibrated star, which has information at the site. And if the data is very good, those results are going to be fairly close together. If the data is less good, there's going to need to be more of adjustment as you move towards calibrated sites. I think that is sort of one of the pieces. I think a second piece that it's worth sort of thinking about is around sort of what this actually focuses on. And because STAR is framed around reducing global species extinction risk, which is sort of one of the main pieces of Goal A of the Kunming-Montreal Global Biodiversity Framework, it focuses on threatened and near threatened species. And those are often, but not always, the species that people care the most about. And you might have a particular site where someone really cares about a very sort of charismatic species for reasons that are different than its extinction status. And that's not going to come out in this type of analysis as sort of a highlight. And so we think about STAR as an ingredient, like one component of a prioritization exercise, but it's not the whole prioritization exercise. Because when you're choosing to do actions at a site, there are going to be other considerations like geopolitical environment, political context, safety, economics, sort of cultural significance of different species that are going to be taken into consideration there. I think the other piece that we're thinking about is that because the way that the official definition of species biodiversity values species biodiversity, every species counts the same. And that's going to come through in this analysis. And that means that places that are really going to drive a lot of the signal are going to be species that have very small ranges and are threatened, like amphibians that live on mountain tops near the equator in the cloud forest. Those are going to be sort of very powerful drivers of the signal, and very widespread species are not going to show up as much because you don't have as much ability to affect the changes in those species if they live over the course of the entire world than if they only live in the parking lot where you're actually working. And so while those all reflect reality, they don't necessarily reflect people's sort of preconceived impressions of what it means for biodiversity. Some of the other pieces that we saw, this metric was very specifically designed to focus on threats, because those threats are they're the things that your actions or your investments can affect on a time scale that is reasonable for a project. But one of the things we discovered across sort of all of the testing is that people still think about individual species more than they think about threats. Whereas a threat lets you look across a lot of different things. A threat is what lets you go from the co-benefits of a different type of action to STAR. People also really want to know about the individual species because those are the things that we identify with. And so changes have been made in how the data is aggregated and sort of held to be able to pull out those individual species scores too, because those are one of the things that people wanted to see. Say those are some of the kind of general trends that we're seeing here. And also a question to the, or something to the chat here, just an observation. You're going to get this recording, you're going to get the slides, and if more questions come up afterwards, that email address there, star@iucn.org, is the place to act those, and then we can tap the entire team to help you answer them.
Thank you so
I'm
much.
seeing one right now, Veronica,
Yeah.
from Kathy Adams about is it user friendly or is training needed, recommended, and does IUCN offer a tutorial? I think the answer to all of those questions is yes. It is user friendly or training needed. For example, to use the contributions platform, all you need is the polygon where you're working, or knowing that it is in a key biodiversity area or in a protected area. You need to know where or even a point associated with it, and then the score gets calculated automatically. But in terms of tutorials and guidance, those are definitely helpful. There are guidance documents that already exist and webinars that already exist on that slide that I showed, but we're also developing ones tailored specifically to this audience here that should be very useful. And alongside this, there are a number of other types of training documents being developed over the timelines of between now and the World Conservation Congress in October to make it easier and easier and easier.
Yeah, thank you so much, Nicolas. I was about to say that there is one question in the chat, but you were very much faster than me. And please, for all of you, we will be sharing Nicolas' slides, both in French and English. And of course, you will have access, but any questions you may have, you contact the STAR team directly, or you can always go through the NAbSA, and we will put you in touch with colleagues. Well, it seems like the audience is getting more active. So we have a hand which is raised. Is Milika Radanovic? So, Milika, if you would like to go ahead and ask your question.
Can you hear me?
Yes.
Yes. Okay, thank you both for organizing this webinar. It was very useful, even though there was a lot of information and this is completely new for me. So sorry if you already mentioned this, what I'm going to ask. So it's about threats and actually assessing threats. So I understand that these threats are predefined based on red list, right? But when we speak about calibrating STAR, is there a possibility to introduce some additional threats that are very local specific, and then to assess them? I'm asking this because, for example, it can be really, something that is related, let's say, to management practices. And ideally, if we show that they are problematic, let's say, for the species, then we can use it. I mean, I see this tool as very useful for advocating towards governments, maybe to support projects as well, because they can see that the result of the project can actually contribute to their contribution to CBD. So if we would be able to assess these local threats and to show that management practices, for example, should be changed, then it can be really, useful tool for advocating the changes.
That's a great question. And I've just put in the chat the IUCN threats classification scheme. In sort of theoretical academic land, there is absolutely no reason that you can't measure the change in a threat at a site that you don't think fits in the threats classification. The bit where it becomes hard is linking that score back to the global score, because the ability to combine information across all the sites in a country and all the sites across the world relies on using the standard classification system. That's if you sort of change what you're measuring in different places, it's really challenging to combine the information together. However, I think the threats classification scheme is actually quite comprehensive. By definition, it means it's frustrating to use because the buckets are pretty big, but because the buckets are big, it means that it can capture most of the things that we're thinking about. And so there are a number of sort of different levels there. And I think what I would probably find is a way of tying the threat that you care about into the classification, then when you're measuring a threat, don't try to measure the big sort of, I don't know, human intrusions and disturbance. You're not going to have an indicator for that. You're going to have a finer grain indicator based on what you know is happening at that site and the thing you're measuring that's going to be tied to the much more specific threat that you're talking about. The big buckets of the threats classification are just what let you speak the common language as all of the other red list assessments done around the world, all of the other STAR sort of analyses done around the world, and what let you walk it back. But I think absolutely, when you measure the thing, it's going to be sort of a more specific threat at a finer grain. And I'm almost certain you're going to be able to tie it back to the threats classification. And then aggregating up is just how you speak the common language there. It's this constant trade-off between specificity at the site and ability to use the sort of common data, which requires a standard protocol across the whole world. And the way that we get around that is we use the fairly common data for the estimated analyses, and then the finer grain site-specific data gets to the nuances of what's actually happening in the site.
Thank you.
There's another question that's come up in the Q&A, Veronica. Let me go ahead. So the question is around STAR relating to in situ threat with species, and can it relate to threats outside the site, like upstream threats that affect the interest in the site? And I think the answer is yes, absolutely. We're driving it sort of, when you're doing an analysis, it's punching out the area of interest, which is around a buffer relating to that threat. But some of the things we're doing is often replicating the STAR analysis at increasing buffers around a site to see how that particular threat might change as you're coming down and looking sort of more specifically. You can imagine that this is particularly important in freshwater ecosystems, where often sort of the source of the pollution might be happening fairly far upstream. And these sort of pieces are being tied in there. I think where this is going to happen in sort of the most interesting ways are in the calibration of STAR, where there's going to be specific information of what's happening at the site. And in those cases, it's totally reasonable to say that the threat that is impacting here is actually happening somewhere else. And so we're working on that threat, but we're tracking the realized STAR that we're achieving back through that particular site. It's just going to be a local situation that is changed differently, but still it would let you aggregate back up and talk to the sort of big STAR globally writ large.
Thanks, Nicholas. I don't need to do my looking for questions. I was looking for that question and you replied before. I said that something in the Q&A chat. I would like to ask one question for also for the audience here today that came for the first time to hear about STAR. If some of the colleagues here in the chat were about to start a STAR process, so what will be the basic ingredients that they will need for having the STAR recipe?
This is a really good question. And essentially, all you need to know is where the area that you care about is. You need to be able to draw it on a map because it's spatially explicit. And this is sort of, I don't know, maybe one of the big differences between at least a certain interpretation of climate data and biodiversity data is that the place where you are has unbelievable importance in biodiversity. And so you need to be able to draw the place you're working on a map. That's really it. That's all you need. And you don't need to be able to do it accurately. Sometimes you just put in a point and create a buffer around it. And that lets you either interact through the contributions platform if you are associated with IUCN or associated with Global Affairs Canada who are entering in your projects, or get a free account on the integrated biodiversity assessment tool and generate a report for that site. And then that will lead you directly to an automatic calculation of star that will tell you which of the threats at that site can achieve sort of the most reduction in global species extinction risk. And then you can look at that and say, okay, I'm going to plan actions around those. Or maybe you look at that and say, I am already doing these actions. Can any of these actions be tied to these threats? And then I can look at the slice of that opportunity that I may already be working on and take it one step deeper. But the place to start, I think, would be the slide that I shared that has all the links on it. And just take a look at some of the guidance documents, or wait a couple months and see the guidance documents that we are going to prepare for you specifically.
Well, that was very, very clear and going into the point. I find that there are not any more questions, but definitely, as Nicholas say, and re-emphasizing, you know what, we are always open. You can always contact us. Maybe something will come to your mind later tonight before going bed, or now while you are having your second coffee of the morning. So please don't hesitate to reach us out. And okay, we have a last question here. Do you work also on emerging threats? I don't know if Angela, you would like to come in and just say it aloud to your question, if you would like to elaborate a bit more. Yes. Okay, I give you the floor. Angela, please, now you have the floor. No. No, so
I can
Nicholas,
answer the question in general.
emerging threats. Yeah.
And the answer is no, we don't really know how to do this yet, or we haven't figured out how to work this into the math yet. It's certainly a problem. And so you can think, for example, because the way that the threat data makes itself into the metric is through red list assessments. And red list assessments, they have a bit that comes in on sort of new and emerging threats, but they haven't sort of worked up into the data of STAR yet. It's working on threats that are currently happening to species. And there's something that the STAR sort of committee is currently trying to figure out how to do, but the math is a little bit more complicated around emerging threats or threats that you see coming down the pipeline, but which haven't happened yet. The way that I think this is particularly interesting is around invasive alien species. So you can see, and that's sort of a kind of threat where knowing that it's going to happen is way more valuable than knowing that it is already happening. And so, for example, in the analysis that we did in across Europe for the EU invasive species target, you can see sort of where the spatial work is happening on the invasive alien species. And you can see places where the threat might not be there yet, but it's coming. And that lets you know to sort of look out for it. And in the same way, you can think about this in a calibration. If we know that a species is threatened by a threat globally across its range, and we know that in our calibrated site, we are not seeing that threat, but we do know that the species is susceptible to that threat, then that's a way of identifying that we need to be on guard against that threat in the specific site there. And I think, I mean, the big one that many of us think about a lot is climate change, which yet is not yet at the level of threatening species in terms of their extinction risk as sort of agriculture or sort of overexploitation or habitat destruction, but we all think it's going to be. And so figuring out how to guard against that and quantify that is sort of a massive challenge that the work is happening on right now. But really fabulous question, putting your finger right on one of the things that we're working on.
Lovely. Thank you so much, Nicholas. I find like it was a very productive session. Honestly, I learned a lot about STAR. And also we have the possibility to have you as an expert to respond to our questions. With this, I would like to say a big thank to you for kicking off this Wednesday of Science. We are just thinking about spring, so we are in the run-up to spring. And thank you so much again. For all of you colleagues that are still with us, just for you to let you know that we will have still a couple of more sessions. Next week, we will have the red list of ecosystems. And for beginning of February, we will have another colleague presenting on natural capital accounting. So we are not over yet. And as I mentioned, please do contact us if you have any question. And Nicholas, he really is very open that you contact him. So thank you so much to all of you. And we will share all the presentations, videos with you. See you next week.
Thank you, everybody. Bye-bye.